Now we will discuss this very important theorem called de Moivre's theorem. This will actually form the basis of nth roots of unity, cube roots of unity, and all of that. So there are two statements in this theorem, and look at them very carefully. If your n belongs to z, right, that means if your n is an integer, then cos theta plus I sin theta whole power n can be written as cos n theta plus I n sin theta. So as we know, according to Euler's form, this can be written as e power I theta. So e power I theta whole power n can be written as e power I n theta, right? And e power I n theta is cos n theta plus I sin n theta, right? So if n is an integer, then things are very simple. Simply you will bring this n down along with theta. So n will come down along with theta. But the trick is when your n belongs to rational numbers. That means if your n is of the form p by q, and for instance if it's not an integer but just a rational number p by q, then cos theta plus I sin theta is very important, one of the values of cos theta plus I sin theta whole power n. So if your n was an integer, I will say cos theta plus I sin theta whole power n is equals to cos n theta plus I sin n theta, right? If your n was an integer. But if your n is a rational number, then this value is one of the values of this, right? So you might have more values also. You might have more values which you know, if you equate this and this, you'll get the same value, right? But this is definitely one of the values, but not all the values, right? If your n is a rational number of the form p by q. This is what your de Moivre's theorem is. Let's look as to how we can apply this theorem in finding the different roots of unity.